Imagine a world hundreds of millions of kilometers from the sun, a place where the sky is black, surface temperatures hover below -200 degrees Celsius, and any exposed liquid water would freeze instantaneously. This is Jupiter's moon, Europa. At about 3,122 kilometers in diameter, it is slightly smaller than our own moon. But its surface is covered in a complex network of reddish-brown fractures, signaling an active geological history. Those intricate cracks suggest the ice shell is constantly shifting. Scientists have concluded that this solid exterior is actually a lid, floating over a vast global saltwater ocean. We can visualize this hidden sea scale. The smaller sphere represents all liquid water in Earth's oceans combined. The larger sphere represents the estimated volume beneath Europa's ice. This tiny moon holds more than twice the water of our entire planet. This environment challenges our traditional understanding of habitability. A world hundreds of millions of kilometers from the sun's warmth has become a primary target for finding life beyond Earth. Maintaining a liquid ocean requires significant energy. At these distances, the sun cannot provide the heat, which means the energy keeping this massive ocean liquid must originate from within. The engine driving Europa is tidal heating. As the moon travels along its orbit, Jupiter's immense gravitational pull constantly squeezes and stretches Europa's interior. This movement generates internal friction. The rock itself grinds and bends, radiating enough thermal energy to prevent the subsurface water from freezing solid. Evidence for this liquid layer was gathered in the 1990s, when NASA's Galileo spacecraft executed a series of close flybys. Galileo's magnetometer detected a specific magnetic signature around the moon. The data is most accurately explained by a global layer of electrically conductive salty water moving beneath the surface. Jupiter effectively replaces the sun for this hidden world. Its gravity provides the mechanical energy required to sustain a dark, liquid environment. If you travel tens of kilometers down through that water, you eventually hit rock. A large volume of water alone isn't enough. Life also requires the exchange of minerals and chemicals. We often associate life with photosynthesis and sunlight, but we can find exceptions to this rule at the bottom of our own oceans. Thousands of meters deep on Earth's seafloor, hydrothermal vents pump superheated, mineral-rich water straight out of the planetary crust. Microbes cluster around these vents, using chemical energy rather than solar energy to fuel their metabolism. Those organisms serve as the foundation for entire food chains operating in total darkness. If Europa's tidal heating generates similar activity on its rocky seafloor, the interaction between hot rock and salt water could create a comparable chemical environment. Europa appears to possess the fundamental components required to sustain biology: liquid water, essential chemistry, its internal energy, and billions of years of stability. On Europa, the potential for life doesn't depend on a star. It depends on the chemical reactions occurring in the dark. Investigating this ocean is a massive technical challenge. Current engineering cannot transport a drill capable of boring through tens of kilometers of solid ice. However, the moon may be venting its own contents into space. Data from the Hubble Space Telescope has shown evidence that Europa occasionally produces plumes of water vapor. These plumes could act as a sampling system, carrying material from the deep ocean and ejecting it into the vacuum where a spacecraft can reach it. NASA is sending the Europa Clipper to investigate. Scheduled to arrive in the early 2030s, the spacecraft will perform nearly 50 close flybys to analyze the surface chemistry and any material escaping into space. This is a reconnaissance mission focused on habitability. Its primary goal is to determine whether the ocean's environment is capable of supporting biological activity. Detecting organic molecules would be a major milestone, but these are just the building blocks of life. A habitable environment is not necessarily an inhabited one. The true shift in our understanding comes from discovering an unmistakable biological structure. Even a single living cell would change our perspective on the universe. Every organism we know on Earth belongs to the same family tree. Biology on Europa would represent a second genesis, life that emerged and evolved completely independently of our own. Finding life on two different worlds within one solar system would suggest that biology is a recurring consequence of the right conditions. It would mean that Earth is not a singular accident, but one of many possible homes for life.